Hi everybody, my name is Ronnie, I'm from Incredibuild, and I wanted to start this session with this cartoon. There's a programmer sitting in front of his laptop and compiling and waiting until the compilation is over and saying, I hate programming, I hate programming, I hate programming. Now when the compilation ends, he says, yay, I love programming. One of the sad things about it is that this is from around 2 decades ago, this cartoon. And unlike other things in tech, this is one thing that really hasn't changed, really hasn't improved much. And it's just getting worse and worse because we're writing more and more and more code all the time. But that's actually why we are here with Incredibuild. So what we are is a development acceleration platform. And we help you build faster. Maybe just a few words about myself. Before I joined Incredibuild, I was many years, like 15 years in different roles in R&D. I was a developer, a development manager, did a little bit of DevOps, and I really felt, the pain of large builds. I actually used Incredibuild whenever I could. That was the first tool I would go to, so I was really happy to join Incredibuild now, become part of the solution. So I wanted to tell you a case study of one of our customers, one of our recent customers. It was a very large automotive company, and they took on a really challenging, very ambitious goal. What they wanted to do is reduce the time that it takes to build a car from 5 years to 3 years. So that's, almost mission impossible, right? Do the same things that you do, just a lot faster. Completely crazy. And obviously, it's not just about software. They had to change a lot of things, around their organization. But software has a lot to do with that. So with that company, we were approached by one of their departments, development departments. They develop driver assistance tools using QNX, if you guys are familiar with that. And they had really long builds. These are the numbers that they shared with us to show us what they did. So they had builds ranging from 1.5 to 2 hours, even longer. This is just one example. When you have 1.5 or 2 hour build, you cannot build on every commit, right? You can't wait that long. So what you do, you start bundling lots of commits, lots of pull requests together to one bundle, and you compile it together. And when you compile it together, when it breaks, and it does break, that's kind of Murphy's Law, you have no idea who broke the build. You start playing that, that fun blame game that's going on of who broke the build. We had another story, even more extreme, from another customer of ours, that this process took so long. What they did was nightly builds. So nightly builds is like, probably the worst because your build fails in the middle of the night. There's nobody there to look at it. You wait a whole day until somebody comes to the office. Then you start playing that fun blame game all over again. It's very frustrating for developers. They don't like that thing. It's not a fun environment to work in, but also really scary for managers. Because you look at that build and you're saying, I don't know when this is going to converge. Is it going to be ready tomorrow? Who knows? You don't know if you're going to meet deadlines. So with that customer that were in kind of this loop, they came to us, they tried out Incredibuild, they deployed it for this specific time, for this specific build, and they actually got it down to 16 minutes. They had, I'll show you later, there are also ways to further optimize that, but they got it down to 16 minutes, which is actually, it's a game changer in that sense. Because 16 minutes now is something that you can build on commit. You can do fast iterations. You can get really fast feedback and complete your work much faster, get much better predictability. So they were really super happy. They deployed it in one of their teams, did like a training, showed it to the developers. They all said, when can I start use that again? When is it getting to us? So they're now kind of distributing it across the organization. And the nice thing that all of that happens without any changes to their build tools, to the build scripts. They didn't have to build a big project of refactoring everything and reorganizing everything. It's just plugging it into your existing build scripts, and it's sort of seamless. So how does this actually work? It's, like I said, it's a development acceleration platform, and it has two aspects to it. So the first thing that we do, we build a grid. That grid is actually a collection of machines. For us, it's a lot of cores. It can be any machine around your organization. It can be on-prem, your build farms, however you manage it. It can also be on the cloud. If you don't have enough resources on-prem, or you have enough resources, but there are certain crunch times where you need more compute power, what you have is not enough, you can also scale to the cloud, burst to the cloud, use compute resources over there. What we do, we install a very small, lightweight agent on each one of these machines, which makes it into a part of the grid. And we have a certain unique virtualization mechanism that really transforms it into a build machine. You don't need to install there all your build tools. So each such machine, you don't need to set there your build tools and your build systems and your code and all of that. It's just any regular machine. You install a little bit of Incredibuild there, and it makes sure that it knows it gets everything that you need in order to run a build. After we set up that compute grid, we take your build, or, by the way, other CI processes, and we break it down to microtasks, to a lot of microtasks. For each such task, we first search for it in the cache, because if you already handled it, already compiled it, it's there in the cache, no need to redo it. That's what caches are for, right? That's why they're invented. For the things that do need to be processed, that do need to be compiled, we just distribute it in the grid. Every such agent, take a little piece of task and run it all together. And what that means is that if, as a developer, I have a 16, 32 core machine, like a regular standard machine, I suddenly, transformed it into a supercomputer with hundreds of cores, as many as I like. I start running the build, and instead of using those 16 cores and taking a lot of time, it just distributes across the grid. It can work for developers, CI processes, obviously, as well. You can use it with your own build systems, compilers, tools, whatever. Those are just a few typical examples we see a lot with customers. We support Visual Studio. We are actually embedded within Visual Studio, but also, CMake. We work with Yocto, QNX, you name it. We also support, different orchestration mechanisms. So you can use it also with Jenkins. It's not coming to replace Jenkins. It just takes whatever environment you have and make it work faster. So let's take maybe a more detailed dive into what your build looks like. The title here, the anatomy of the build, what your build actually looks like. So this is a bit overwhelming. I'll explain exactly what you see here, all these colorful things. But just to say, this is a build. It's an AGL Yocto project build. It's a nasty one. It can take 3 hours on a 16-core machine. This is what it looks like when you put the Incredibuild glasses on. Typically, when you look at the build, all you see is a console window, a black console window with lots of text, an error here and there, right? That's what it looks like when you look at it in Incredibuild. So I'll explain what you see here. So on the left-hand side, you see this list. It's just a list of all the cores that participate in your build. Like I said, this specific build, we ran it with the 16-core machine. So the first 16 rows are the first 16 cores that you can actually run your build with. But here, the grid contained 80 cores. So if we're scrolling down, you can see more and more and more and more and more cores participating in your build, actually transforming this from 16-core to an 80-core machine. If you had 200, it can be also 200, no problem. All the middle part, all the colorful boxes, those are actually the microtasks that we broke the build into. Those microtasks, typically like an obj file or something like that, and just distributed it across the grid. Let me zoom out a bit. This is the zoomed in, but if I zoom out more and more, you can see the magnitude of what's going on here. So imagine all the yellow boxes at the bottom, starting from the 16th row down, those are things that get distributed on the grid. I don't know, that's really exciting. I love looking at that specific image. I'll let you reflect on that for a minute. It's a fun thing. And again, you don't need to look into it. If you just run your build, this is just a view. The developer runs the build, the CI machine runs the build. All of that happens in the background. You don't need to do anything except look at it and enjoy the view. But there is something, some really helpful insights that you can also take from the build, other than just what you distribute. So there's a lot of actionable insights, actionable data that you can use in order to further optimize your builds. Because just taking things and distributing it is great, makes it work in parallel, but we can do better. So what you can see here at the top, all the graphs in the top, they show you in every second of the build execution what was the CPU usage, what was the memory usage, what was the I/O. Because sometimes your problem is not about CPU. Your problem is that you have a bottleneck with I/O. And if you fix that, you boost your build even further. Every red bar is something that ended with an error, like with a return code that is not 0. You can look into it, see the details, see what happened to fix it. But I think that the really interesting thing that you can see is why doesn't everything get distributed? So if I zoom out again, what's bothering me is that it's all very nice, but there's a lot of white space here. Why can't I take that white space and just fill it with green bars, just make the build run faster, make things move, start earlier, run faster, do a lot more parallelization. So what you can do is really look at what your build looks like, where the white spaces are, and figure out what's going on there. For example, all these tasks over here, they all start at a certain point. Are they waiting for something? This is exactly, a dependency in the code. Now, you can look into it and say, why do I have this dependency? Is it really needed here? Can I get rid of it and push everything here to the left? What you can also see here are some of these tasks, some of these bars are really, really long. Why is it so long? Why do you need something that takes so long and cannot happen in parallel? You can look into these tasks and see if it can be broken down. Sometimes it can, sometimes it cannot. I mean, it depends really on your build, on your logic, on a lot of things on your code. But sometimes they're just, stupid things that can be done to make it run a lot faster. So that's really, the anatomy of what a build looks like when you look at it at Incredibuild and the kind of insights that you can get out of it. So let's talk a little bit about cloud. Like I said before, we can do that either on-prem or on the cloud, or hybrid model that just bursts to the cloud on demand. I don't know, how many of you here are already compiling on the cloud or considering compiling on the cloud? Raise your hand if you do. Okay, a little bit, good. I mean, it's picking up, right? I mean, there's a lot of concerns that we know from many customers, but it's picking up and we see more and more customers doing it. We have just some kind of flash news, recent news from 2 days ago. We have a partnership with the AWS. We just won the Migration Partner of the Year award, so we were working really closely with them. We obviously support all other cloud vendors as well. And the question is why actually build on the cloud, and why build it on the cloud with Incredibuild and not just buy a lot of core power in the cloud. So first, cloud, that's something that is easy to scale up and down. You don't need to commit to certain hardware. There are peak times, there are slow times. Things change, the world is dynamic, so that helps you do that. And with Incredibuild, we actually let you scale it up and down even further. What we do on the cloud is for computation, we use spot instances, which is actually kind of idle cores on the cloud that you can get for a really, really, really cheap price. But the thing is that it can be taken away at any time. So it's not a good solution if you just want to start a build on a spot instance. But if your spot instance is part of a bigger grid, if it's taken away, you can just replace it in a second and continue your build. You didn't lose time. It's really seamless. You won't even notice that something happened. So we make really good usage of that. It really fits that grid concept. Also, cloud, by definition, has high availability, less need for maintenance to keep track of the machines. They are up, they are down, they need all kinds of work. That's kind of trivial. And with our caching technology, it means that you need to go to the cloud only when you actually need to build something. Otherwise, if it's cached, you can save the efforts. So we really let you use the cloud only when it's needed, pay for the resources when they need it. If you need extra compute power, you need to go to the cloud, you can do that. If not, you don't. So just to summarize, what we're all about is saving you time, getting iterations faster, accelerating builds and other CI processes. But it's not the only thing that is important. If you're coming to add an acceleration partner, if you're coming to add a new solution to your IT system, you're probably thinking about more things. You don't need something that is kind of low maintenance, secure, obviously, talking automotive here, that has very low footprint. And what's also very important is that it's flexible. We don't force you to change the way that you do things. We're not a build system. We support build systems. So it is flexible. It allows you to use your own tools the way you use it, and kind of self-serve and seamless from the developer's perspective. They don't even need to know that it's there. They just run the builds. It's plugged in. It's working. And whenever you also, if you think about your future stack, things that you're going to evolve, new tools that you're going to add, it's not limiting the way that you do things. This is something that can grow together with you.